Welcome back. On today's lecture series, we are going to discuss about loss formula derivations. So here, the first of all, we have to do an empathy. So like an system engineer and system operator and a design engineer and triple students, they're having the several empathy among the community. So here, in system operator, he may ask, why does dispatching the cheapest plan far away still cost more overall? And the design thinker is thinking and is asking, having the sum of empathy, how do I account for line losses in my economic dispatch model? As a triple students, and he have the empathy, the equal incremental rule, that is nothing but a lambda rule breaks down. What formula replaces when it when loss exit? So based on the empathy, we have to define according to the gap, the equal incremental cost. It rule. It ignores the transmission losses and it goes to the suboptimal scheduling. And here we are always expecting the total losses. That is nothing but in power loss PL as a function of generator outputs, like the power generated from the unit 1, unit 2, unit 3 up to unit n. That is nothing but P1, P2, Pn. So the main objective of this loss formula derivation, it is to determine the B coefficient. That is nothing but loss formula. So we just to enable the optimal dispatch with losses. That is nothing but in the transmission lines. So in the ideate stage, in order to derive the B coefficient for the loss formula derivation, the first step, we have to assume a reference bus. The reference bus is nothing but a slack bus. So in the system, the power system, it consists of a number of buses. Among that, any one bus can be assumed as a reference bus. So here, the all current expressed relative to one that particular reference node. And in the second step, we have to express a line current in terms of generator injections. So for this, we have to use the current distribution factor IK, which is equal to summation AKI into I. So here in the third step, we have to compute the total losses. That is nothing but an heat loss or power loss or voltage drop, etc. That is nothing but I square R losses. So in the transmission line, the power loss is equal to summation I square R. I is nothing but I K square. R is nothing but RK. This is for all transmission lines. And in the fourth step, we have to substitute the generator power expressions. So for that, we have to replace the current, which is equal to PI divided by VI cos pi. VI cos pi. So from this, we can derive the loss formula derivation. That is for power formula. Power loss is equal to summation I, summation J, PI, Bij into Bj plus summation I, Bo I into Pi plus Boo. So by using this, we can able to formula, we can able to arrive the coefficient, that is power loss formula. So in this power loss derivation, we have to make some assumptions. Number one, the load power factor as assumed as constant, or it may be a fixed value. And the bus voltages has to be also assumed as constant. And the transmission network is assumed to be linear, it is not in non-linear. And here the system, it does not contains any shunt capacitance. And the power factor of the generation, it should be fixed value, it is not a variable one. And we have to assume the balanced three-phase system instead of unbalanced three-phase system. So these are the assumption in order to derive the loss formula derivations. So here in the Bij, it means mutual B coefficient, BOI means linear B coefficient, BOO means constant term. So here also we have to determine the penalty factor and the revised coordination equations. So for this step number one, we have to apply the Lagrangian equation. So the main objective of using the Lagrangian, we have to minimize the fuel cost for that particular unit, which is subject to the total generation minus total demand minus the total power loss, which is equal to losses. That is nothing but the total generation, which is equal to total demand plus total losses. And also we have to go for lambda iteration method. So dou L by dou Pi, which is equal to 0. That is nothing but an incremental method. And from this we can able to get the revised coordination equations. And from this we can able to determine the penalty factor of alpha height. So here, so this is a numerical example. Here the B11, B22, B12 and the power demand of unit 1 unit is given. So by substituting in the loss formula derivation, we can able to get the power loss, which is equal to 51.25 megawatt. So for this we can use the incremental transmission loss formula also. We can use the penalty factor also. So how we have to validate? Here, if we are increasing the unit generation, so the dou L by dou Pi also increases. That is nothing but, and lambda iteration also increases. If the random iterations increases, the penalty factor is also gets increases. One. And also in the symmetrical matrix, Bij is equal to Bji, both are equal only. And in the limiting case, if the power loss is equal to 0, so the alpha value has to be 1. And we have to use the lambda iteration method. And then for the practical limitation, B coefficient are valid only near the operating point used to derive the loss formula derivations. So these are the real-time applications. It can be used for the energy management system like SCADA and some of the platform to monitor the real-time economic dispatch and the electricity market pricing and the renewable energy of solar, wind, which is integrated with the smart grid, which is to minimize the fuel cost and also minimize the grid losses. And this is in summary. So in the loss formula derivation, why we have to implement the equal area criterion and what is losses, and what are the assumptions we have to make, and what is the loss formula how we have to derive, and what is the penalty factor. So this is an accurate challenge. May know the answer. Why does a cheap but distant generator sometimes cost more to use? If you know the answer, I'm giving the hint. If you know the answer, just to put in the comment section. And this is another assessment with respect to the conceptual. And they state the revised coordination equation for economic dispatch with the transmission losses. Why is the penalty factor alpha is always greater than 1 for typical system? So you can use the chat box to know to put the answers. And these are the few references for this topic. Thank you.